Good afternoon, everyone, and welcome to AABC's Tab Talk webinar series. I'm Colleen McCain, Marketing and Member Engagement Manager with AABC, and I'll be your moderator for today's webinar. Thanks to all our members and non-members across the community for participating today. I have a few housekeeping notes before we get started. If you have questions for our speakers, please use the Q&A button in your Zoom window and not the chat, and we will feed those questions to our speakers at the conclusion of the presentation. You can submit questions at any time, no need to wait until the end. If you have technical issues, please use the chat box to inform the panelists and we will assist you. And finally, concerning AIA Learning Units, if you are a certified TBE or TBT, please allow 7 days for your CEUs to be uploaded automatically to your portal. Today's session topic is HVAC Retrofit Projects, what the TAB and CX professionals need to know. Our experts joining us today are Josh Green of Environmental Test and Balance Company and Duane, Ekela, and Jason Stiles of AABC's newest industry partner, Trane. Trane brings efficient and sustainable climate solutions to buildings, homes, and transportation, making high-performance buildings reliable, healthy, and efficient. And now to introduce our presenters. Duane Ekela has over 17 years of experience with building systems in various vertical markets. Currently, he works at Trane and leads a team of project developers and energy engineers for the greater Northeast. He has extensive experience in performance, contracting, project development, and design build turnkey. Previously, Duane has worked as an engineering team leader for Control, has led energy contracting, and has performed new and existing building commissioning services. Duane has a Bachelor of Science in Industrial Engineering, is a certified energy manager, and a building commissioning professional. Jason Stiles has an extensive background in design and functional testing of large, complex mechanical HVAC systems. Since 2005, he has developed his career by working in roles as a certified AABC TAB technician, controls automation technician, controls project engineer, and is currently in a controls account management position at Trane. Jason's expertise in building automation and control applications is backed by a well-rooted foundation in functional testing, balancing, and commissioning of complex systems, including hospitals, biocontainment labs, industrial plants, and commercial real estate. And finally, Josh Green is the Vice President of Operations and Senior Project Manager at Environmental Test and Balance Company, the leading authority on testing and balancing, commissioning, and clean room certification projects for Memphis and Mid-South. Josh has been with EC&B since 2001 and has 20 years of experience on a variety of HVAC and construction projects. He also manages the company's in-house training program and looks forward to training and developing EC&B's new hires. Josh has expertise in providing independent TAB, commissioning, and clean room certification services for all types of HVAC applications, including healthcare facilities, office and retail, food service, research facilities, and laboratory environments. Now I'm going to hand it off to Josh to get us started. Take it away.
Well, thank you to Colleen and for the introductions, and also thank you to Jason and Duane from Trane, our new industry partners, and all the work they put into this presentation. Really appreciate it. And I've worked with both of these guys in their past lives, including roles in TAB and commissioning, and now with their roles in performance contracting. And I think they're going to bring a unique perspective to the conversation here today. So thanks, guys. Okay, so introduction. What is a retrofit project? So for the purposes of this webinar, we're going to define these projects as projects consisting of installing new components and controls in an existing system. So these projects serve the needs of our customers, including delivering the energy efficiency aspects, but they also function to maintain or improve the occupant comfort and IAQ levels of the facility. But we do need to keep in mind, though, throughout this presentation, that this is a team effort that's needed to achieve a level of quality of the installation, and also the verification of the components and controls is also key. So few points about the stock of existing buildings. So when you step back and think of the number of existing buildings out there, the market really opens up. So nearly half of the 6 million buildings that are in use today were constructed before 1980. And the efficiency of today's building systems are much improved as compared to then. So this leaves some ample opportunities to improve both the existing building market using the enhanced retrofit process. Now, also regarding the retrofit market, out of the entire building environment, only 1 or 2% is actual new construction or major renovation. So with that, that's 98% of the market is existing buildings and that have a potential need. So there's an immense opportunity in this field. So energy use and just energy in general is a very relevant topic, especially in today's world. And as we'll discuss, energy is a major driver in these projects. A 2020 study found that buildings consume 40% of the energy produced here in the US. And in a given building, 40% of the building's energy is driven by the HVAC systems. So when you package that all together, it equates to roughly 16% of all the energy produced is being consumed by HVAC systems. And with the cost of energy increasing, along with the environmental impacts, owners are keeping all of this in mind. So with public buildings, there's been some increasing codes and regulations affecting the decarbonization. So they're somewhat forced to comply with these codes and regulations. And with privately owned buildings, owners are using this as an opportunity to market sustainability. So HVAC technology, advanced HVAC systems and technology. This allows for both comfort and for energy efficiency. Today's systems allow for variable volume, multi-stage operation to maintain conditions, and also to provide the humidity control. In order to accomplish this, though, controls and sequences have to be installed and implemented. And I believe the need for HVAC professionals to interface with these controls to properly set them up and tune the systems this need will continue to increase. And so when you think about it, systems now are not able just to be simply set in place, powered on, and then operate correctly. So tab firms and other HVAC building professionals will definitely need that skill set of controls knowledge, as well as the ability to commission these systems for proper operation. So before we get in to the meat of the discussion, I want to quickly highlight what a focused energy retrofit project looks like as compared to just a like-for-like replacement. So a retrofit project focuses on and is an energy-driven project. So owners' requirements such as sustainability goals, net zero, decarb requirements are considered and are factors in the decision process. And this also includes the IAQ component involved to provide the required ventilation rates and occupant comfort. So often energy audits, return on investment calculations have been performed to analyze payback. So in contrast, an equipment replacement project may not be driven around energy efficiency or sustainability, but it's simply when older equipment has just reached its useful life. Now, with today's systems, there may be an energy benefit built into the new system, but the project goals may not be green energy focused. So again, as Duane is about to discuss, these retrofit projects focus on the bigger picture of leveraging our current technology to achieve the owner's requirements of energy efficiency, net zero, reduction of fossil fuels, and with keeping the needs of the occupants in mind.
So next, we wanted to highlight some of the drivers and benefits that you'll see in construction and buildings, specifically with owners now and in the near future. So we wanted to highlight some of those key components here. And what we're seeing is, a drive for more sustainability, a drive towards net zero buildings, renewables, specifically solar, PV, and wind, and then repurposing existing buildings and you'll be able to use the space more effectively and smartly. Electrification and decarbonization's also a focus going forward in certain areas of the country, which we'll touch on in a moment. And that's primarily through updating codes and standards to making sure that those things are happening in specific areas. And within that, also evolving technology is kind of encompassing everything together, because all of these items are evolving at a pretty rapid pace. But Aside from that, there's also been a lot of stimulus funds and federal funding here in the near past. So that's also been a big focus as to why these retrofit projects are happening. So we'll dive into the renewables that I was mentioning just a moment ago, and really that is expected to grow by 80% by 2050. So what this means is that projects will be utilizing the energy savings and the utility spend in the facility to maybe have a capital needs project that's coupled on the backside, but the driver that you may not see while doing the project may be something produced by the renewables on that site. So that's one area that may be a driver that you see now and in the future. Another is basically the need within the grid expanding upon that. So, right now in some areas of the country, there's only one-way transmission. I want to highlight that energy is only flowing into the facility, and really the next step is going to be moving to an environment where it flows in both directions, and where there's the ability to produce electricity on site and also receive it. And then with that comes the need, right, for smarter buildings. You've got LED lighting, energy efficient equipment, smart appliances, smart phones, electric vehicle charging on site. And all of those are, also potential drivers for a retrofit project within a facility with energy at its focus. And really the future that we're going to go to next would be on-site energy storage and on-site production. So really a move away from needing the grid, and potential for eliminating the need for certain types of power plants, specifically coal plants in certain areas of the country will go away, and the actual site that you're at working on will be producing its own power. And another driver kind of expanding on that, and maybe even a bigger goal for certain facilities, and maybe part of their facility goals is to achieve a net zero facility. So they may go to the point of only using what they actually produce on site and not requiring any utility from the grid itself. Another driver right now that we're seeing in the industry is the policies that I was mentioning. So New York City, Massachusetts, specifically Boston, and the Pacific Coast have all got policies that they put in place right now around decarbonization, and that's they're driving that through incentives and rebates in those areas. And it's not stopping there, right? You've got the 3+ on the map, and it's expanding into other areas of the country. And really the takeaway here is that this is going to be a growing need into the future, well into the future, and that energy is a component of it, but decarbonization is also a big focus in the near future. In addition to that, we've got a lot of new products and technologies that are incorporated into these projects. So electrification and heating, which is a part of the decarb strategy. You've got advanced controls and energy services now, and you've got on-site renewables and batteries. And these are all combined together to a cohesive project in some cases, or a lot of cases, where these components are all working together in tandem to reach the goals of the facility. And lastly, I wanted to touch on the funding that I've mentioned. So this is just one area, but there's been a lot of funding put into the economy through COVID and the response that the government has had there. So a lot of the projects that are happening across the country right now are funded by these. And this example I have for ESSER 2, ESSER 3 is the funding specifically for schools. And within the school systems, a lot of projects right now that in the past were capital need projects now have been converted into projects that are utilizing this funding.
So basically, to build off of what Duane is talking about, and we've seen the drivers, but now we need to know the types of projects we need to be looking for, and kind of examples of those projects, right? So based off of this slide, this is kind of how we're trying to frame up, just the approach, right? We're trying to figure out where and when to pull in different phases of the project. The first phase is obviously going to be your number one phase. It's going to be the most important, right? In this phase, what we're trying to do here is bring in a group of professionals instead of just having, a couple guys that are an engineering firm and your owner. We want to start bringing in, multiple disciplines, right? We want to bring in people that it can identify the value and the savings in their specific fields to critique that project strictly for the owner's purposes. Moving into the next slide, what we're going to be seeing is, just some low hanging fruit, right? Like they don't all have to be major projects, right? So we can see just from looking at the ductwork. The ductwork, I mean, older buildings typically have, poor, just really chopped up ductwork because, of retrofits over time or construction projects. So we'll see a lot of pressure loss from system effect and, increased energy consumption just from, bad ductwork. Next things we're looking at is just system leakage as a whole, right? Like not just the ductwork, but the air handling units themselves, terminal devices. So once we get into this range, we're seeing a lot of leakage that could potentially be energy being saved. Like energy, if you think about the leakage, you can see it as money just seeping out of the holes, right? So as a rule of thumb, we typically see around, I'd think it's $750 per 1 horsepower running in a continuous condition. So when you apply that number to here, we're looking at, a large facility that has probably 5 or 6 major air handlers. You can see how that price would just add up quickly. Electrification of heating. So obviously what Duane kind of touched on earlier is the decarbonization. That's becoming a big driver for a lot of the big retrofit problems or retrofit projects that we're putting together. There's a lot of areas that are actually putting together laws and standards based around this, right? So Berkeley, California is one with about a dozen other cities across the US that have actually banned natural gas in all new facilities. So by applying newer systems and designs, you can see that, we can kind of try to capture that wasted energy and use that in, a more efficient way. So another way to look at this is, the building as a whole, right? So you can't just look at one thing like just the ductwork or just the equipment. You have to look at the whole building envelope, right? So that would be something that we would validate, not just coming into this project as, okay, I'm gonna do some rework on your ductwork and give you more efficient equipment. Well, we also need to look at how is all the equipment being tied together? What is the envelope itself? Do we have holes in it? Is it sound, right? So pressure tests on the envelope and things of that nature need to be done because there's a lot of energy being wasted just from static effect and wind driven airflow. So that's one big issue that I think gets missed a lot of times when we do retrofit projects is we're not looking at a building as a whole, we're more or less looking at an individual system. Bouncing off the building, we got lighting, right? Like everybody knows LEDs are significantly more efficient than incandescent bulbs. But what we don't think about is even if a building has LEDs, depending on the age of the LED, right? Like technology advances almost daily. And so like the newer LEDs are really just more efficient than the old ones. So there's still money to be saved in upgrading your LED bulbs. That's one of the points that we need to start driving home too, is just because you have LEDs does not mean you cannot gain more efficiency from your bulbs. Building automation. This is probably, in my opinion, one of the major components to a energy-driven retrofit, right? So when you're installing a building automation system, you're doing it to enhance, the performance of your units. You're also doing it to expand obsolete systems like pneumatic systems and multi-zone units, right? We're trying to automate all this to kind of reduce the workload on the PM guy, the maintenance guy, the preventative maintenance. We're trying to also improve the marketability of the site, and really just trying to give the customer more of an insight into their system that they can maintain and kind of keep those savings rolling through like the time of the project throughout the life of the BAS system. So moving on to the next slide, we got a lot of different options for that, which they're all going to be very specific to the project, right? But there's several things that we can put in here that are, like energy optimizing programming, right? So like Trane has a lot of different things that are click of a button now. Duct static reset, discharge air reset. We're at remote access through VPN cloud services that we provide. So these are things that we didn't typically see, 10 years ago. We didn't really have that kind of technology out there. And the stuff that's coming out nowadays is what is driving a lot of these green buildings. So we need to make sure that we loop in the building automation on the front end. Indoor air quality, right? Like that's a huge thing now. Everybody knows since COVID, like we're all seeing indoor air quality in a different light, right? So it's no longer just about energy savings and unconditioned air entering your building and causing a lot of other issues. So we're seeing studies now that are coming out that indoor air quality actually has genuine health effects. Like it can negatively affect you if it's poor quality, right? So there was a study done in a Danish school system where they found that it had to be a balanced automated ventilation system, but when it was in that scenario, the students were performing better than in non ventilated rooms or naturally ventilated rooms, right? They were performing better on their standardized tests and a bunch of other performance metrics that they were measured on. So just based off of that, the performance of the students, right, and your kids, or even your in your office space, right? You don't want to go to the office and just feel sluggish all the time because you have too much CO2 in the space, or you want to go to a space you feel comfortable in and that is going to help you, is going to help you provide quality work for your company or learning ability for your children. So moving on to the next slide, there are several different types of air moving equipment now, and the technologies with that have just improved greatly. So stepping away, like we're seeing a lot of people stepping away from belt-driven motors, right, or belt-driven fans. The ECM motors, they're usually above 90% on the efficiency scale for the ECM motors versus the older belt-driven fans and things of that nature. So variable volume systems, multi-stage units based off of airflow, and maybe even implementing some discharge air temperature resets, duct static resets, like I mentioned earlier. These are all components in an air moving system that can be added just to give you a flat rate savings with newer technology. So I spoke on the multidiscipline teams earlier, and kind of where we're moving with this is we want to make sure that we don't leave anything out, right? When we develop a project, we want the project to be very tight, right? We want to make sure we don't miss anything. The customer is getting what they pay for, and everything works without a hitch. You know, there's always going to be problems in a project, but getting the right people in on the front end, I think is key, right? So by including our commissioning agents and our tab technicians and TBEs and the manufacturer of the equipment to make sure that the actual equipment is applied in the right scenarios and, you know, things of that nature. Just from the very beginning of the project, we need to incorporate all the people that are going to be involved, the high level people, and just work together to get a clean, concise project together to make sure that we fulfill the owner's needs. That's kind of where we're trying to take that multidiscipline team aspect.
So continuing on with what Jason's talking about, this multidisciplinary team, we're going to speak specifically about commissioning within existing buildings. And I wanted to kind of go through the commissioning process in general so that we can have a better idea of what that component of the team looks like. So starting out, I've got the definition of what is commissioning. So commissioning is a quality focused process for enhancing the delivery of a project. And this is really to meet the owner's objectives and their criteria. It's the focus and the purpose of commissioning is to meet the owner's objectives. It's going to also reduce risk within the project, and it's also going to help with the assessment, verification, and testing, and also the documentation, so that for the long term, the building owner operator will be able to know how the building should be operating based off of the original design intent. So what are the benefits? So the benefits is compliance with that design intent. It's and it's really early in the process. I want to highlight, you know, the pre-design design phase, and in some instances, commissioning agents come in later, and really to have the best commission project is the goal would be to come in as early as possible, even pre-design. Really, conceptual phase would be best, and really the purpose of that is to make sure that when you get all the way through to functional testing, you're testing the system that the owner was intending to have installed in the building, and that when you get to close out documentation, you're wrapping that up in a way that is meaningful to the owner and giving them the documentation that's going to be most useful for them. So within that, there's some additional benefits, and one of the things that I wanted to highlight here is some future technology that's being utilized now in some cases. So you see QR codes on the screen, and I wanted to highlight that. So one of the projects that I was specifically involved with, what we did was we utilized a QR code on the piece of equipment, the air handler. You go up with a smartphone and you're able to scan the QR code, and it pulls up not only the O&M documentation for the unit, but also the functional test, also the tab report, and any other pertinent information to that specific piece of equipment. And the good thing about this being a QR code, it's linked digitally, and it can be stored indefinitely in the cloud and updated at any point in time. You don't have a printed document that's sitting there. And really the goal to have an effectively commissioned building is to have that documentation to be able to continually be updated over time as the buildings change, needs to change, or the design intent maybe modified down the road. You can easily update it. But all of this is following, you know, the ASHRAE guidelines, and that's really what's kind of driving the process of what the commissioning process looks like, all the deliverables included, and who the key stakeholders are. And actually within this guideline 0 that's out now from ASHRAE, it specifically highlights the roles and responsibilities in the project. And that's really important to make sure that the key players are involved throughout the process, and that everybody that's on the team knows everything that's required from them from the beginning of the project. And next, I wanted to highlight that there is actually a payback, simple payback associated. So because of the way that the commissioning process is within a building, the study has been done by Berkeley here that basically the energy savings has been has increased to the point where the cost that's involved with commissioning has a payback somewhere in the range of 2 to 4 years. And that's been documented time and time again, that there's a benefit to having a commission agent involved. And really the goal, like I was mentioning before, is that it's ongoing commissioning. This is not a one-time commissioning event. That the plan includes documentation that's going to be continued over time. And a couple of the ways that that's happening right now, one is monitoring-based commissioning, and the other is fault detection and diagnostics. So monitoring-based commissioning actually will automatically perform functional testing on facilities. There's certain analytic tools that can be used now that overlay on top of the building automation system, and that will automatically flag anytime that the system doesn't operate as designed. And then fault detection diagnostics basically can help with preventive maintenance. So you can predict when the system's going to fail, when you need to change belts, filters, and help the maintenance staff be proactive and not reactive to when equipment has failures. Next, we're going to talk a little bit about the energy management component. So within energy management, it's a very critical component of this infrastructure. And really the commissioning process has a huge impact on this, as I mentioned, the simple payback just a moment ago. But in 2018, energy demand grew to the fastest pace in decades. And we did see a little bit of a turn in that back in 2020 during the pandemic, specifically in commercial buildings when people started to work from home more than they did in buildings. And, the overall building use dropped, but the home use rose quite a bit. But that's expected to shift back, and we're still figuring out what the quote unquote new normal is that we've been talking about for 2 years. But it's expected to return. So we don't know what's going to happen next. But with wind and solar, those are definitely going to be continuing. I showed earlier at the kind of the beginning of the presentation that that's going to be significant growth through 2050, right? And that digital driven assets is going to be a big push going forward. But as it stands right now, China, United States, and India account for about 70% of the energy rise across the world. So what does this energy manager for services and deliverables process look like? And really it's all the things that are mentioned on the screen here. We're starting with an energy audit and energy modeling of the facility all the way through to the project delivery and then verification. So we'll kind of go through that process now in a little bit more detail. So at the very beginning, we want to baseline the building. The baseline, as you see in the pie chart to the right, top right, is one facility as an example. I do want to point out that every type of facility has a different ratio for consumption. All those consumables you see, lighting, water, heating, they change building by building, and also they change across the country. So it's critical to get all the things that you see on the bullet points on the screen at the front end of the project. So you're wanting to know the utility spend, all the utility data, the type of the facility, the type of the construction, and then you're using that to create the benchmark. And really the benchmark is typically in a couple different key components. We're either looking at the energy use intensity, or we're looking at the cost per square foot of the facility. And we're using that and comparing it against similar facilities to see how well that facility performs. One of the tools that's out there is actually Energy Star's Portfolio Manager. So you see that picture in the top right, and that is an industry standard that's used, but it has its shortfalls. So it's a good first indicator, but to actually go through and perform a full benchmark will give more clear results to the facility. And then after we've done that, then it's going to be going to the energy audit step. And depending on the type of facility and the need, and then also if it's a guaranteed project or non-guaranteed, then we're going to have to provide different levels of audit. So there's a level 1, 2, and a level 3 audit, depending on the type of project and the funding source. After that audit is completed, then we have to evaluate the results of the audit. So that's not just what's in the facility, it's how the energy is used. It's also rebates and incentives, other key components to making the project cash flow, where it's going to be cash flow neutral to the customer in a lot of cases, where they're not going to potentially pay for anything. It's the energy savings pays for it. So this evaluation determines that ratio, and if that is possible for the project that they're looking to have completed. After the project is gone through that evaluation, then it's actually implemented. And those energy saving measures, ECMs, are what's typically executed at this point. through the implementation process. And during that point, a lot of times a performance contract, it can be either guaranteed or non-guaranteed is what some customers utilize to do that in their facility. But after it's completed, really the most important step is to make sure that it's performing, that you've got the energy savings realized that you thought that you had at the beginning that you predicted. So that through the M&V process, both pre and post installation, comparing the two, we'll be able to determine if actually those energy savings are going to be utilized in the facility. And those results are then given back to the owner of the facility so that they can make informed decisions.
Thank you, Duane. All right, so engaging TAB on these projects. So I think there's going to be some challenges in this market. I know there are. So one challenge that I think TAB providers that we're going to face is the involvement on the projects. So as you'll see on the next slide, what we're going to be talking about is when TAB is involved. We want to get involved early. We want to get involved, during the design phase. And Duane, I don't know if you can advance the slide, just one. Thank you, sir. So, so we're going to highlight at what stages of the project where we're going to get involved, and also the added benefits to the project. We're going to discuss the TAB processes and what TAB processes are needed to serve this market, and also the training and continuing education requirements that are going to be needed to keep pace with this technology. So some highlights here. So often TAB is seen as like an end of the project task, or just checking a box at the end of the job. But the energy savings from the improved system performance is accomplished not only by balancing the end product, but by the early involvement to perform the drawing reviews, provide key measurements, and provide an analysis of the existing conditions. So with existing buildings, thorough pre-testing often uncovers quite a few issues and reveals a lot more than just a pre-construction walkthrough might find. So in addition to the experience working in existing facilities, the independent TAB process brings that non-biased, accurate measurements and analysis to the attention of the owner, the design team, and the performance contractor for their consideration. And we've been talking about the multidiscipline teams. TAB firms are already well-versed and experienced in working with not only engineers and design professionals, but also contractors, commissioning agents, other skilled trades to provide the owner with a working system at the end of a project. So I think timing is everything on this, and the earlier that we can get involved, earlier TAB firm can get involved in an existing building retrofit, there's more opportunities that we're going to have to enhance the project. So in addition to that, documentation of the as-found condition, it is going to assist the design team in understanding the operation of the current system, and also to determine if the proposed modifications of the retrofit will achieve the owner's requirements. So design reviews can be done early, and these are going to verify that the balancing devices are installed and accessible. And also during the review, we can perform our checks to determine if the terminal unit quantities match up to the air handling unit quantities. We see that a lot where you add up the terminal units and they don't quite match up to the AHU. So all this will uncover issues that are much easier to address early than later. So from finding missing and deficient components, providing analysis on the operation and distribution of the systems prior to that renovation, the cost payback from early TAB involvement is much higher. So as we discussed, energy savings and system performance is kind of built in, to these systems and also to the TAB process. And with energy, it seems like there's always a trade-off. So for example, you could just easily raise the thermostat in the space by a few degrees and save some energy. But today's systems, they're going to allow for that variable volume, multi-stage, multi-speed compressors to both save energy, maintain comfort, indoor air quality levels, and humidity control. And so what this graph illustrates is fan law 3, and how important it is to get these systems set up properly and to not over deliver airflow, because just a 10% more airflow delivery is going to result in a 30% more energy to drive the fan. So in an energy savings project, it's paramount, I believe, to set these systems to the design flows to ensure those energy savings. So one thing about data, and I think it should be accurate, meaningful, and repeatable data. So there are some steps to ensure that we get that, and one of them is on the design review of the plans to verify that we've got the placement of the balancing devices, that they're installed correctly, that they're going to be installed correctly, and that they're going to be accessible. And then the reviews can also provide recommendations for additional ductwork to minimize system effect losses, and also to allow us to get total airflow measurements by traverses. Using the proper instrumentation, including duct traverses, we're applying it properly. Our instrumentation is calibrated, maintained, and applied properly. And so a key component, I think, to this is putting our experienced and trained technicians on the project. And this is important, not just for the evaluating and the troubleshooting system operation that an experienced technician can bring, but also that they understand what the project intent is for these jobs. So I think that is important. And then, and lastly, a detailed tab plan is written for each project, and then that we incorporate our standardized test forms so that we can get the test data and it can be properly documented. So one challenge that retrofit projects often face is the field verification and calibration of control devices. So if we get out and do some pre-construction, pre-demo testing, we can use that time to document control set points. And we found this is especially important in hospitals and critical spaces. And so documenting these static pressure set points, outside air set points, and what have you prior to demolition and replacement can save some time during the final balance and the reprogramming to those pre-demo set points. And also, so during final tab of verification, that all the safety devices, airflow measuring stations, control sensors, all these sensors are installed, operational, and reading correctly. And with as much time as our technicians in our firm spend in front of the equipment, who better to do this than the tab industry? And if the CXA is involved, if there's commissioning involved in the project, the tab process will provide those reliable control points for the system commissioning. If there's not commissioning involved in the project, the tab firm, I believe, should at least be verifying that the sequences are meeting the design intent. And so with today's systems becoming more complex, there's additional interaction that's required to engage these systems in order to vet the controls, ring out the issues, and who really better to do that than tab and commissioning and working with the controls. So, like I said, with the complexity of these systems today and the pace of change that's happening ever faster, I think training our people is that much more important. I'm a firm believer in training, and I've witnessed the level of performance from a properly trained technician compared to one that hasn't received that level of training. So it's definitely an investment in the person and in the industry. So if you don't have a structured in-house training program with a dedicated 3-year curriculum, I believe you should. Like I said, it's an investment in not only the technician, but in the business and also in the industry. And so our in-house curriculum centers around the technician training manual, and also we use the national standards and the CAHO manual as part of our curriculum. Another great resource that we've tapped into is the EAB's Engineered Air Balance, their training center in Houston. At last check, they had 3 classes that they were offering. And we've actually sent some of our techs down to those classes, and the feedback that we've received is great. You can see the impact in the technician and in their work. And I personally visited the training center, and it's state of the art. And I encourage not only TAB personnel to attend, but others in the building professional, industry. Look into these courses because they're high quality.
So I'm just going to bounce kind of back into the multidiscipline team, and it's going to kind of build off of what Josh just described about the TMB and the CXAs. Moving into the next slide, we see we got a little puzzle piece structure here trying to portray the current standard project development approach, right? We have the owner, we have the design team, the installation team, TAB, and then closing out the project, right? We're not incorporating everybody in this situation. It's just basically the standard project where, you go into it, you do your walkthrough, and then the project starts flowing. So kind of what we're trying to do here is step away from the standard project and then step the game up, right? We're trying to provide a better product to the owner and actually, make the industry a better environment and a better teaming situation to where we're not all siloed off in our own little, in our own trades. I mean, when we could drop to the next slide, we kind of can go into the, bringing in TAB firms, right? And bringing in commissioning agents, the customers, IT, facility operators, right? Like if you're going into a building that's definitely going to be a retrofit, who better to ask the questions about the building than your facility operators? I mean, they work there every day. They know it inside and out. So getting them on the front end and getting their input is, in my opinion, extremely valuable. Having the TAB contractor and the CXA contractor just working together, right? So we'll have the TAB do a pre-demo test, and they can report their findings back to the project developer and then also the commissioning agent, and help the commissioning agent develop his plans of action. The IT group, right? Like if you're going to be running into a lot of building automation, you're going to have to figure out what their network infrastructure is like, how all that's put together. Can you have remote access? Can we even be on their network? Like these are all things we have to ask in today's day and age with cybersecurity and everything. So bringing the IT group in, what we're kind of getting at here is ensuring success through teamwork, which is this slide here. This is kind of a comprehensive look at the way we would like this to be set up here. Okay, so where the other slide actually had missing pieces, now we're bringing in owners' representatives, the CX provider, the maintenance and operations team, IT, architects, engineers, equipment manufacturers, electrical contractors, control contractors, the energy management and TMB. These are all things that I think should be started at the development phase and then push through, because that's going to provide a cleaner product in the end result. And also it's just going to make the project go smoother, right? Like we're going to be bouncing ideas off each other. We're going to be moving into, different aspects to where, take a controls aspect, like the control vendor may not have the experience that the TAB industry has, right? The TAB contractor. So these are all things that we need to make sure like we're pulling together. And the whole point of this, I guess, slide deck right here is that, teaming is a great thing. And then retrofitting these projects in the proper manner will give you several different things. That's going to be going beyond the like for like replacement. We're going to be providing a better environment for, the future generations to come, right? Sustainability, decarbonizations. These are all things that are not just for us now, but for our generations to come, right? And then by doing this, even the owners are going to be seeing return on investments, right? So it's not just a one-sided, hey, let's do this now for our generations to come. No, this is actually, let's do it now. At least we can self-fund these projects by our savings and then grow our green marketplace, right? We want to just make the world a better place in the end of the day. And I think starting here and in the HVAC industry and combining the teaming is key. So next slide. Oh, thank you.
Okay, thank you, Jason. All right, I think we're ready to open it up to questions. Colleen?
All right, thanks, guys. We do have a couple questions that came in. Let's just start with the first one here. I see Duane is actually typing an answer, but I'll go ahead and ask it just so everyone can hear the answer. Question is, there was a lot of discussion about the importance of ductwork envelopes, IAQ improvements, etc. How are these measures commissioning in a retrofit project versus new construction? How can modern BMS be used to better commission these items?
I'll take the first stab at this one. I thought it'd be easier to talk through this than to type it in the chat. So I think the first part of that, so retrofit versus new construction, I think in some cases, retrofits don't have as good of documentation from the architect engineering side. You know, there's not plans and specifications, and it's not going out to bid. In a lot of cases, a lot of those are directly purchased from the owner. And because of that, those documents need to be conversations instead of, you know, plans and specs that are already kind of pre-drafted. And I think that's a big component. It basically, the discussion's got to happen throughout the project and not been responded to based off of those plans and specs. And with the modern BAS and CX, that half of the question. So how can that help through the process? And really, it's data. So, you know, having a lot of sensors in the space, trending the right points, and utilizing that data to be able to determine if the facility is operating correctly. And that also feeds back into IAQ and improvements, because if you don't have a building that's operating effectively, if you have the data there, you can use that to support it. Envelope, for example, if you're trending the building pressure, you can look at that and say that potentially you have an issue with an economizer in the building, or maybe you know, if the temperatures are in the space aren't being maintained, maybe the discharge air reset's not working correctly. So data around all of those is really kind of the answer. And then being able to have the conversation with the owner up front, not only with the data, but also with the requirements and how to measure the project through that data is a critical component to having successful projects.
All right, great, thank you. Let's see if we have any others. All right, we have Michael asking, do you have experience addressing building envelope issues and commissioning of existing buildings with your team?
I guess I'll jump in and take this one too. So this is what I do quite frequently. In fact, I've done it on a couple of facilities here just recently. And, you know, sometimes we'll hire a vendor to go through and assess the envelope. There's vendors that specifically do that, and underneath that ECM, they would be, you know, responsible for that scope. However, you know, we also do that as well. So one route is through thermal imaging. So you can use thermal images to see if there's air moving in or out of a facility, if there's air leakage. You can tell that from the image that you get. You can tell that also, you know, by the temperature that you're seeing transferred through the surface, and see how leaky it is there as well. And then also on-site measurements. So sometimes I'll engage a tab contractor to go out and take some field measurements to better understand where the airflow in the building is going. And then, you know, also through surveying the building, some buildings you can just walk in and tell. They've got exhaust fans everywhere and no outdoor air coming in, so you immediately know they're negative. And there's got to be a balance, right? You've got to have enough outdoor air coming in to equal out or be a little bit more than the exhaust, so the building's neutral or positive. And assessing all those on site are great ways to be able to determine that and see what the next step should be. Colleen?
Okay. And we have another question from Steve. It's a tab item. Speak to your experience with oversized branch ducts and standard non-edge sealed volume dampers, creating excess flow conditions at damper full close.
Yeah, so I'll jump in here and grab this one. So, yeah, we, as a matter of fact, we've got a project right now that we're seeing, we've seen that condition happen. And actually it's partly, design. It's hard to catch those things as far as, looking at every single branch duct, calculating what the velocity pressure is going to need to be through the duct. But we've got projects now. We've got a project now that's happening where we've actually had the contractor come in and install, some orifice plates to bring down that velocity, and then we can use the balancing damper to fine tune it. So yeah, we've seen that.
All right. And I do see, Duane, you're typing up some answers here. Did you want me to also ask these just so you can get some input on them from the other presenters, or are you just happy with the typed answer?
Go ahead. Yes, sorry.
Okay, perfect. No problem. Just wanted to check with you. Question from Laura. There was a lot of discussion about the importance of ductwork envelope, IAQ improvements. How are these measures? How are these measures commissioning in a retrofit? Did we already go over this one?
I believe that was the first question.
Okay, got it. Okay, it disappeared from my chat and popped back up, I think, when you were typing the answer. So let me double check here. I think we have another one from Steve. All right, and did we also do Steve's first question here, Duane, that you had responded to? Can the Trane team speak to the market experience with heat pump equipped central air handlers and their associated controls, including pros and cons?
Yeah, so I listed a couple there. There's definitely other pros and cons to speak to about that. I mean, it's so new right now. I think maybe we don't know all the pros and cons yet, honestly, because this is kind of where the industry has just shifted in the last couple of years. In fact, Trane's ramping up currently with new products. They've just released some new products that meet this need in the marketplace, and I think there'll be more to come.
Great. New question from Santanu. There was some discussion about net zero energy building goals in some approaches and metrics towards achieving them. But what are your recommended approaches towards net zero carbon buildings and some of the associated metrics? So,
one is figuring out the total usage of the facility, but in a lot of cases, and I guess, Jason, I'll tee it up to you to give this example, but some facilities are using metrics outside of their facility in other locations, right, to be able to offset that. So you can actually purchase carbon offset. So Jason, I'll hand it over to you.
So there's things called power purchasing agreements. And so what a lot of people do, they can actually just pay money to someone with a solar farm per se, and they will basically introduce that energy back into the grid. There's other virtual ones where, well, that would be the virtual one. The other one is a power purchasing agreement where they buy property elsewhere in the US, right, that has land that they can actually put a solar farm on or something of that nature, and generate that power and introduce it back into the grid. So basically what they're kind of doing is there's a lot of different ways to achieve that, whether that's from certificates or the power purchasing agreements or putting on-site decarbonization technology, in the facility, but there's a number of ways out there now that people are actually trying to achieve the net zero.
Really, to kind of summarize it, the overall goal is twofold. It's reduce and then produce. So you want to reduce the energy consumption in the facility, and then you're looking at production, and then hopefully you get to, the net zero.
Net zero. It's the offset, right?
All right, thank you. It is 3 o'clock. We do just have a couple more of those softball questions, so I'm just going to read off these and then we can wrap it up. So first question, do tab agents prefer direct drive fans controlled by a DFD for balancing?
So I'll jump on this one. So yeah, absolutely. It's a lot easier than, the shiv and belt days. But, one thing about it is it does take some coordination, with the controls vendor to make sure those set points are documented. And so documented as the default set point too, because we've seen sometimes where you lose the controller and it's reverted back to a default setting that wasn't the balance setting. So yeah, we do agree. They're helpful, but you got to document those set points.
Okay, question 2. In a chiller retrofit project, how much of the existing system should be commissioned?
Duane, you want to get on this one?
Yeah, sorry. So, ideally, it's going to be to the extent that's going to accomplish the design intent, right? So typically it's going to be the entire system if you can. The only way that you really can get there effectively is through analytics. So it's a combination of on-site verification and remote verification a lot of times to get to that 100%. So you maybe a sampling of 10-20% on site, and then you're sampling the rest off-site through analytics, unless the first sampling yields results that need further investigation. But ideally, you want to sample the entire system if possible.
And doing cross-season checks as well, right? Because when you do it on site, you're only getting that point in time in that one scenario. So the cross-season checks and using your BAS system as a tool that can actually give you the data across the several different shoulder months and times of the year that typically you have issues. I think utilizing the BAS system is going to start being more of a commissioning tool as well as a building operating tool.
Okay, and very last question. If my customer has a building with 20 air handling units, should we retrofit all of them at once or individually?
So yeah, if the budget allows, go for it, right? But there may be some impacts as far as energy efficiency motors that you could tap into now, depending on how old and how inefficient the motors are. So that's one thing to think about is, how much is that motor costing you still in operation? And if there's 20 units, you multiply that number by 20. Jason had a good comment earlier detailing what the cost of just 1 horsepower. What was that number, Jason?
$750.
$750 for 1 horsepower to run continuously for a year. So you multiply that by the horsepower requirements for each one of those units, and you can see how it could significantly add up if those motors or components could be retrofitted for if there were more efficient options out there.
Yeah, and I think that too, a lot of times the customer's budget, right? You got to worry about that too, right? They may want to do the full 20 units, right? But it's not feasible with their budget. So figuring out which units would have the most payback, right? And then funding the rest of those units in a manner from their savings is probably, the happy medium. Obviously, if you were able to do it all at once, all that payback would come in at once. But, depending on how the customer has their budget set up and the goals they're trying to achieve, that's all very flexible. So just try to keep in mind when you're doing these retrofit projects, it's not just about clearing out the old with new. It's also about let's stage this up with the customer to make sure that they can actually afford to do the project, right? Like we don't want them to strain themselves out and overextend. And then that's just going to be an unhappy customer at the end of the day. So just keep in mind that there are ways to divide and conquer, right? That's kind of where I was going to go with that anyway.
All right, thanks so much for sticking around for the Q&A. I'd like to thank our presenters, Duane, Jason, and Josh for lending us their time today. Thanks, guys. Awesome presentation. We hope to see everyone in Orlando this April for CX Energy and the TAB and CX seminar. If you haven't already registered, please log online and do so. And the TAB Talk webinar series will be taking a hiatus in the month of April and will continue on May 18th at 2 p.m. Eastern with a talk on fire smoke damper testing and fire life safety system maintenance. Thanks again, everyone, for joining us, and have a great rest of your day.
Thank you.
Thanks, everybody.